Hey, welcome back, guys, and we're continuing with section 1 of part 3. We started in the previous video. In this video, we're going to be covering this subsection on writing conditions. We're going to do the exercise the following exercise on numbers. Hopefully, we'll get through the second reading and these three exercises in this video as well. And we'll probably finish the remaining parts of this section in part 3 in the following video. If we can condense everything into 20 minutes while I can still make sure that I give out as much context as possible in the material that we encounter, I'll do that. If not, I'll just break it into a separate video. Okay, so writing conditions. Any Boolean expression or combination thereof is a valid condition in a loop. For example, the following program prints out every third number, but only as long as the number is less than 100 and not divisible by 5. So we have our initialization iterator, also known as our initialization variable called number. It takes in an input. Then we have our while loop, and we have our condition here. Right? It's a combined condition. We have one side that checks that number is less than 100, and another one that checks that our number is not divisible by 5. And then we're gonna print number and increment number by 3. So these are two examples of the program's execution with different inputs. So if we provide 28, right, it's going to check, is 28 less than 100? Yes. And is 28 not divisible by 0? If so, which is true, so it's going to print 28. So it's going to print 28, then it's going to add 3 to 28. It's going to go up to 31. Then again, it's going to check, is 31 less than 100? And is 31 not divisible by 5? Both are true. It's going to print 31. Then it's going to increment 31 by 3, becoming 34. It's going to ask, is 34 less than 100? And is 34 not divisible by 5? Both of those conditions are true. So it's going to increment to 37, and so on and so forth. So it's going to keep incrementing until we either get to a number that is equal to or greater than 100, or if a number that is divisible by 5. And that's going to be what gets us out of this loop. Right? If we start with number 96, for example, so it's going to check, is 96 less than 100, and is 96 not divisible by 5? Both conditions are true, so it's going to print 96, increment that by 3. Now we're at 99. Is 99 less than 100? Yes. Is 99 not divisible by 5? Also yes. It's going to print 99, increment 99 by 3, so now we're at 102. Is 102 less than 100? No, 102 is greater than 100. So this side is already false. And for this to be true, both sides of this AND operator have to be true. So if we have one side that's false and one side that's true, it automatically evaluates to false. So we're not going to loop back. We're not going to go print 102 and then increment by 3 again. When the input is 28, the loop ends with the number 37 because the next number is 40. Right. Is 40 less than 100? Yes. Is 40 not divisible by 5? No, 40 is divisible by 5. 40 divided by 5 is 8. So that's where it stops, at 37. When the input is 96, the loop ends with the number 99 because the next number is 102, which is not less than 100. Whenever you are at a loop, you should make sure that the execution of the loop will always end at some point. The following program either finishes or doesn't, depending on the input. Number equals integer, right? We have the variable here, our initialization variable, also acting as our iterator variable, storing an integer value. And it says, well, number is not equal to 10, print number, right? So if we start with a number that's less than 10, for example, as it down here in the example, if we plug in 4, right? 4 is not equal to 10, which is true. So we print 4, then we add 2 to 4. We're going to do that over and over until we get to 8, right? It's going to print 8, and then it's going to increment 8 by 2. Then it's going to check is 10, which is going to make 8 into 10. So number is not equal to 10. Then it's going to check, is number not equal to 10? That's false. Number is equal to 10, so we're going to terminate this loop. But for example, if we enter a number greater than 10 as our starting number, then it's never going to terminate, right? Because 11 is greater than 10, 12 is greater than 10, an infinite remaining number of numbers is going to be greater than 10. It's never going to equal 10. So we're always going to be in this loop forever. So which is what explained down here. If the input is a number greater than equal to 10 or less, then the loop will terminate. Otherwise, any number greater than 10 will be in here forever. Okay, we have another exercise here called numbers. It says, please write a program which asks the user for a number. The program then prints out all integer numbers greater than 0 but smaller than the input. So we're going to have our iterator here, initialization variable, as well, also known as, it's just going to take in an integer, prompting the user for an upper limit. Then we're going to say, while number is less than or equal, please don't use the value true as the condition of your while loop in this exercise. So we want to print, so it'll be number less than, actually no, that's not true. I think we might need a helper variable here. All right, tracker is equal to 0, while tracker is less than number, print number, increment tracker by 1. So if we plug in 5, we should be printing tracker. There we go, 1, 2, 3, 4. So let's test this. And that's true. So, I mean, that passes. So you might want to name your variables here a little bit different and be more contextual, right? So instead of just calling a number, you can call it what the prompt is, right? Upper limit, like that. And remember, if you remember, I taught you guys this shortcut. If you double click on a variable name and click it anywhere else that it shows up while holding Alt, it's going to highlight both instances. And then you can just, on your keyboard, type in a new name like that. So it updates them both at the same time. And then here we're going to have our tracker variable. We just leave that as the same. You can even call it iterator or whatever, or just number if you want. But I think this is a little bit more contextually appropriate. So again, if we run this, enter 5, it's going to print 1, 2, 3, 4. And again, if we test this, we should pass the test. Let's view the model solution, see how they did it. Right, so they did the same thing. They have a variable that checks, that keeps track of the upper limit. They called it limit. We called it upper limit in our code here. Then they have another variable called number. This is our helper variable. And then check, is number less than limit? Print that number and then increment number by 1. So same thing. Is tracker less than upper limit? Print tracker, increment tracker by 1. Okay, debugging tips. Imagine you're writing some slightly more complicated program, such as the one in the next exercise, powers of 2. The first efforts could look like this. Limit stores an integer value. Tracker variable number is equal to 1, while number is equal to limit. Do this stuff. Here the program starts with reading the input and continues with the outline of the loop and some attempt at a condition. It is likely the code will not work as desired on the first try. It might have to be tested dozens or even hundreds of times before it works correctly. This bit of code always asks for input from the user, which makes testing it slow and cumbersome. Each time the program is tested, input must be typed in. One way around this is hard coding the input while testing. So we can hard code our upper limit and then use that in our condition for the loop when we're testing our code instead of having to each time typing a new number over and over and over again. When the program works with one hard-coded input, it is easy to test it with other hard-coded inputs as well. When it seems to work correctly all around, it can be tested with input from the user. This trick works with many of the tests that exercises on this course are graded with. If the test tells you that the program works incorrectly when the input is, say, 42, that input can be hard-coded into the program while you look for the source of the bug. And this is why, if you've noticed, whenever I run the program with the solution that we come up with before submitting, right, what do I always do? I always use the same test values that are given to us. So for example, here in this exercise, it provided 5 as the upper limit, so I used 5. But you can use any other limit that you want if you want to test it over and over a couple times before you submit it. But I know that if I pass this test 99% of the time, it means my program is going to pass all other tests that maybe have been written in the background that we don't get to see yet. So you can hard code these values. For example, if your program is supposed to take in an input, hard code a simulating value, run your program, see if it works. If not, then it will help you debug your program. So where do we leave off? This trick works with many of the tests that the exercise on this course are graded with. If the test tells you that the program works incorrectly when the input is, say, 42, that input can be hard-coded into the program while you look for the source of the bug. So we limit 42, numbers equal to 1, then here's our loop, and then the rest of our code. The print statement debugging was mentioned a few times in the previous part of the course. The programs you are asked to write will become more and more complex as the course advances. The amount of debugging you will have to do will likely increase accordingly. Common causes for bugs lie in the conditions that terminate loops. They may work correctly for some inputs and fail for others, and it is not always obvious why that is. That is why it is high time you included print statement debugging in your programming practices, if you haven't done so already. You can find debugging instructions in the first and the fourth section of the previous part. Besides print statement, there are links here that you can click. I'm assuming that you're following along on your own computer and you're also viewing the material in real time. So there are links here to the first and fourth sections from part 2. That's when they talk about debugging print statements. And I've also covered them in the video, one of the videos in the past. I'll probably link it in the description below. If I forget, somebody remind me in the comments. Besides the print statements, there are many other tools that can be used for debugging. One of these is the visualization tool on the Python tutor website. The tool allows you to execute your code line by line and also shows you the values stored in variables at each step. The slightly broken code from the debugging example in the previous section is visualized with Python tutor in the following image. So if you go to pythontutor.com, start visualizing, you can type in your code here. This is the same thing as we've been doing for this does a little bit more where it tells you what's happening with each step. In the past, I also talked about Python Playground. You can bring your code over here, or if you see a code block here that the material doesn't cover in detail of what the code does when it's run, you can come and plug it in over here and see that code being executed. So Python Playground, Python Tutor is also another one. We'll probably be using this one, Python Tutor, moving forward, as it is a recommended tool. But there are other ways for you to, if you have any other sources and links and visualization tools that you can share, you can put them in the comments below. We'll definitely talk about it in the next video. The tool allows you to execute your code line by line and also shows you the values stored in variables at each step. The slightly broken code from the debugging example in the previous section is visualized with Python tutor in the following image. So we have our variable here called attempts. You can go back and find this in the previous section. This was the exercise that was asking us to have our loop track the number of attempts that we use to reach the correct pin code before we get booted out of the loop. The red arrow points to where the execution of the program is at the moment. You can see the red arrow right here. The tool displays what has been printed out so far and also shows the value each variable has at each step. The execution moves forward line by line as you press next. So if you press next here or previous, it'll go back to either. If you press previous, it'll go back to the previous step. If you press next, it's going to go down to the next step. All you need to do to use the visualization tool is to copy your code and paste it into the code window of the tool. The tool does have some limitations compared to the version of Python used on this course. If you come across any cryptic error messages, it may be better to try some other debugging method. More experienced programmers are rarely heavy users of the visualization tool, but for a beginner, it can be a valuable aid. Programming as a discipline has little room for luck or chance. It is essential that a programmer understands what values are created by their code at any given moment in the execution, And this goes back to my point that I made a couple of times now in some of my previous videos when I was talking about the purpose of me doing this video and the purpose of me encouraging people to still learn how to program fundamentally before touching any code that is produced by AI. Because the AI will spit out something that can't work, and sometimes it will spit out code that doesn't work or that doesn't really work well with what code base that you currently have. And if you don't understand the programming language, right, if you can't sit there and read the code to an extent and understand or get a general understanding of what the code is doing so that you can debug it should it go wrong, right? Or so you can understand why you're adding that AI generated code into your code base and making sure that it has no security vulnerabilities, any performance drawbacks, etc. Knowing what the programming language that you're using or that the AI is giving you is important, especially when it comes time to debugging the code. And in the future, I'm sure this course, maybe not in the introduction course, but maybe in the advanced course, might cover about writing unit tests and end-to-end tests, right, that test your program as a whole, right? So you have to be able to understand what your code is written as and what it's doing for you to write those tests. So this is why I emphasize the importance of still learning how to code, right? Know the language at a fundamental level. Understand syntax, understand format, et cetera, et cetera. Understand keywords, right? So you can know if you're using AI religiously or you're depending too heavily on AI, at least you should understand what the code is doing to some extent. The visualization tool and debugging print statements are both great ways for a programmer to see with their own eyes what a program does exactly what was expected of it. So hopefully that reinforces some of the thinking that I've been trying to embed in your brains, right? Everybody watching this is why we do what we do, right? This is why we're learning Python as beginners, right? I can sit here and make an advanced video teaching you all types of advanced concepts in Python or JavaScript or TypeScript or Java or C++ or the other languages that I know. But understanding the fundamental level, right? Especially understanding for the purpose of being employable, because you're going to walk into large code bases that you might not understand depending on your experience level, if you're a junior especially, right? So knowing at least what the language is, right? What the language is doing, reading the code and saying, oh, okay, they used this type of loop instead of that one. Maybe this one is better for performance reasons or whatever, right? Or, hey, I'm in this code base and they're relying on AI a lot. I haven't worked with AI before, but I have some experience with the language that we're using in the code base, right? If it's Python or TypeScript or whatever else. So when AI produces some code, you can sit here and be like, hey, I know what that code is doing. Oh, hey, I can read that and get a general idea of what the code is trying to accomplish. So when you run the code and it inevitably it shows a bug or some other issue, you can go back and be able to debug it. So this is why I emphasize learning coding at a fundamental level before you start touching AI. Okay, so our first of 3 exercises. Hopefully we get to do them in the next couple of minutes. It's called Powers of 2. It says, please write a program which asks the user to type in an upper limit. The program then prints out numbers so that each subsequent number is the previous one doubled, starting from the number 1. That is, the program prints out powers of 2 in order. The execution of the program finishes when the next number to be printed will be greater than the limit set by the user. No numbers greater than the limit should be printed. Please don't use the value true as the condition of your while loop in the exercise. What are powers of 2? The first power of 2 is the number 1. The next one is 1 times 2, which is 2. The next is 2 times 2, which is 4. The next number is 4 times 1. Okay. Each power is in the sequence is multiplied by 2 to produce the next one. So here we have some upper limit that we can test. So if our upper limit is 8, it's going to print 1, then it's going to print 2, then it's going to print 4, then it's going to print 8. If we do 20, it's going to print 1, 2, 4, 8, 16. And if we do 100, it's going to print 1, 2, 4, 8, 16, 32, and 64. Okay, so we're going to have a variable here called upper limit. It's going to store an integer that we provide. Then we're going to say current number is equal to 0 or 1, since we're going to be starting at 1. We're going to say while current number is less than upper limit, we want to print current number. So let's just do that. Let's see what this is going to do, right? And we're going to start with the lower upper limit. We'll start with like 8. I misspelled something. I did. Okay, 8. Oh, right, we got to increment this. We got to increment current number by 1. Okay, might have to reset this, because sometimes when you go into a loop, an infinite loop, it lags behind. So just hit the reset button. Make sure you copy, right? Control A, Control C, the code that you currently have. Hit the reset button, and then paste your code back in, and then hit run again. So type in 8 here. 1, 2, 3, 4, 5, 6, 7. Okay. So maybe we should set it less or equal to 8. Oh, sorry, I didn't mean to do that. Okay, so now we want to increment this, but in a way that doubles. So I think it should be times equals to. Okay, we got 1, 2, 4, and 8. 1, 2, 4, and 8. Okay, let's try with 20. 1, 2, 4, 8, and 16. Okay, let's try with 100. 1, 2, 4, 8, 16, 32, and 64. So I think that should be our solution. So this is very similar to the exercise that we did, the last exercise that we did in the previous video. This one, where we have a variable tracking the upper limit and a tracker variable, and then we just increment by 1 to print numbers up to the upper limit. So I think this should work. Let's run our tests, see what we do. And there we go. Let's view our model solution. And they did the same thing. They have a variable tracking the upper limit, a tracker variable. Then, while that tracker variable is less than or equal to the upper limit, print that number, right? Print that tracker, the current tracker number, and then increment number by multiplying it by 2. And then go back, and then the loop is going to keep going until we reach the upper limit. So it's exactly what we came up with here. Okay, next exercise, powers of base n. Let me close all these extra tabs so OBS doesn't start lagging. Please change the program from the previous exercise so that the user gets to input also the base, which is multiplied. In the previous program, the base was always 2. So we're just going to copy this. Let's just take a look at this. So we're going to prompt them for the upper limit and prompt them for the base. It's going to print every number, increment by the base up until the upper limit. So if the upper limit is 27, the base number is 3, we're going to do print 1, then 1 times 3, then 3 times 3, which is 9, then 9 times 3, which is 27. That's our upper limit. It's going to stop. For upper limit is 1,234,567. Base 10, it's going to print 1, 10, 100, 1,000, 10,000, 100,000, up to 1 million. Okay. So upper limit base is also going to be an input integer. Then we're going to keep current number. So now it's not going to be current number times or equals 2. It's going to be times equals the base. So let's try it with 27 and 3. So upper limit is 27. Our base is 3. We get 1, 3, 9, and 27. If we try it with, let's try like 45. And our base is 3 as well. 1, 3, 9, 27. Right, because 3 times 27 is what, like 71? So it's not going to print up to 45. But if we do, say, 45 and 5, 1, 5, and 25, and if we do 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, and our base is 10, it's going to print the same thing, our little half pyramid. 1, 10, 100, 1,000, 10,000, 100,000, up to 1,000,000. So that's the solution to this exercise. If we run our test, we should pass, and we do. We can view the model solution. It did the same thing. So they have the limit here, upper limit variable tracker, initialization, and the multiply initialization, we call it the base. Then the tracker variable for the current number. Then we do the same loop formation, and down here, instead of plus equals 2, or instead of times equals 2, we do times equals the multiplier. We did it times equals base. I think multiplier is a better variable name though, so we'll change it to that. So again, if we hit our test, we should pass. Awesome. And now, final exercise in this video. We've hit the 25-minute mark, so hopefully we don't go over 30 minutes. This exercise is called the sum of consecutive numbers version 1. So this probably means we're probably going to encounter this exercise again at some point. Yeah, we do in the next, so we'll do this in the next video. Please write a program which asks the user to type in a limit. The program then calculates the sum of consecutive numbers, 1, 2, so 1 plus 2 plus 3 plus blah, until the sum is at least equal to the limit set by the user. The program should function as follows. The limit is 2, and the sum is 3. The limit is 10, the sum is 10. The limit is 18, the sum is 21. The program then calculates the sum of consecutive numbers. Okay, I see. If you have trouble understanding how the desired output is calculated, the sample output in the next exercise may help. You may assume the number typed in by the user is always equal to 2 or higher. So if the limit is 2, it's going to do 1 plus 2. Okay, I think I get it, but let's just take a look at it. So upper limit, integer, prompt the user for a limit. Actually, I need to wrap this in the input function. Then we're going to keep our tracker here. You know, tracker is going to be 2 or more. So we're going to say while number is less than upper, so it'll be less than or equal to upper limit. What we want to do is print. Actually, no, we should also have a variable here that. So we'll do total is equal to total plus number. Then we're going to do number plus equals 1. And then we're going to print total. So if our limit is 2, prints 4. So let's print total here. So again, 2, current total is 4. Let's put it above and after. So total is 2, and then total is 4. So maybe we should start it at 0. And we should hard code total here, I'm sorry. So total is 0, 0, 1, 1, 3. So if our limit is 2, then our total is going to be 3. Let's try a limit of 10. Okay, total it printed as 55. So that's not accurate. Consecutive numbers, right? So it should be less than upper limit. Nope, it still prints 45. But if our number starts at 2, so let's look at this again. They said if the limit is 2, it's going to do 1. It's going to. So I think number should start at 0. So if total is 0, so if So if number is, let's print current number. In fact, we should start number at 1 actually, I think. So we're debugging here, right? So if our upper limit is 2, number is 1, current total is 0, current total is 1. It's going to print 1. So let's set this less than or equal to 2 to the upper limit. Okay, so current number is 1, current total is 0, current total is 1. Then it's going to increment 1 by 1, so current number is 2, current total is still 1, then 1 plus 2 is 3, then we get 3. Okay, let's try with 10 again. We're still getting up to 55 where the expected answer is 10. Okay. I had to take a second and think about what the question is asking. And it's not asking us to calculate the sum of every consecutive number up to the limit. It's asking us to calculate the sum of all consecutive numbers that to the point where that sum is equal to the limit. Does that make sense? Okay, let's hopefully this makes sense. So down here is where I was able to figure it out. So if our upper limit is 10, for example, this is why I couldn't figure it out with the value of 10 while I was equaling 10. So the consecutive sum of 1 plus 2 plus 3 plus 4, right, is 10. So we want to go up to, so our consecutive sum should be equal to our upper limit. So even if we could do plus 5, plus 6, plus 7, etc., that's not what it's asking us. Just calculate the sum until we get to 10, until we get to the equal to the upper limit. So instead of checking while number is less than the upper limit, it should be our total, because we want that consecutive sum. So I think this should work. So if we put our upper limit as 10, right, and print, so we get up to 15. So this is better. I think if we change this to less than upper limit, we should get 10. There we go. 1, then 2, then 3, then 6, then 10. So if we try 18, our final answer should be 21. Yeah, we get 21. So that's what it was asking us. So we shouldn't have been checking whether number was less than upper limit. We should be checking whether total is less than the upper limit while still incrementing number. Right, number is equal to number plus 1. I like writing it out like this more. It's just a little bit more legible. So we can go ahead and test this. I think you put on only one row. Oops, sorry, so we need to get rid of these. Again, if you hold Alt and then put your cursor on the 3 lines that you want to delete, then press Control-Shift-K on your keyboard. It's gonna erase those 3 lines. So Control-Shift-K. It's gonna erase all those lines. So we have here prompting the user for the upper limit, then the number. We're gonna use that as our incrementer, as our iterator, and then our total. We're gonna keep track of the total of the consecutive numbers. So if we test this, there we go. And let's check the model solution. So same thing. They have a tracker for the limit, another tracker for the current number, and a tracker for the sum. Then while sum is less than the limit, increment number by 1, increment sum by the number, and then print out the sum. So yeah, that's the solution for this exercise. I had to think about it for a second, right? Because it was my brain was working, but I was just this little misconstrued here. And you saw there how we're using print statements to debug, right? You can put them everywhere to see what the values are being printed in the moment. And also, we probably could have used that Python evaluator, right? We just learned about it like 5 minutes ago. We could have used that one too to see what the values are changing as, but for the sake of time, the print statement debugging was the way we went. But that's what the solution that we came up with. So hopefully you enjoyed that, a little bit of debugging, a little bit of thinking about it. Them pointing us to this exercise here was useful for me to be able to see what it's actually asking. Because that way I could know that we need to keep track, compare our total to the upper limit and not the current number to the upper limit. All right, hope you guys enjoyed that video. Next video we'll go through this last subsection in part 1, in section 1 of part 3. And then we'll be done with this part, and we'll move on to the remaining material in part 3.